So to kind of finish up just a little bit then, atomic emission. So we've talked about light being emitted. Atomic emission deals with atoms. So a neon sign. Everybody's seen some kind of neon sign, you know, on a bar, street, somewhere. Light in a neon sign is produced when electricity is passed through a tube that has neon gas in it. And it might not be neon. Argon is common. There's different gases besides just neon that are used to light up signs. But when electricity is passed through that neon gas, that energy excites the electrons, which are the atoms, and causes them to start moving faster. So these excited atoms, because they have electricity providing energy, return to their stable state, and when they return back to their stable state, they give off light. And when they give off light, they release that energy that they've had. So basically it's like this. Inside the atom, if my electron is here, it absorbs energy and it jumps up a level. It's excited and it moves in the atom. But once it moves, it wants to come back down to its normal state. And when it comes back down, it releases energy. And when it releases energy, it also releases light. So absorbs energy from electricity, it hops up. Releases energy, it comes down. And when it's releasing its energy is when it gives off a light. And I will show an example in my classroom of how that works. So I can look at hydrogen gas, I can look at any kind of gas. And then if I use a prism or a spectrometer, I can actually see the lights or the spectrum that's given off by that element. Every element has its own spectrum. So this shows it a little bit better. The atomic emission spectrum is the set of frequencies that it gives off. So here, if I look at the spectrum, here are my wavelengths that are actually there, and I can see exactly where or what part of the spectrum that element gives off. So for example, if this is hydrogen, I see the purple, the blue, light blue, and red. If I had helium, I might have a line here, here, and here. Every element gives off something different. So the atomic emission spectrum is the set of frequencies specifically for that element. And every element is different. It's like a fingerprint for that element. And in order to actually have a very nice picture like this, you need a spectroscope, and it'll print it out and you can see it, and I do not have that in my classroom. So, to wrap up, how do wave and particle natures compare? Wave, we're going to look at the electromagnetic spectrum. We're going to use the wavelength. We're going to use the speed of light. Particle, we're going to look at Planck's constant. How is a quantum related to an energy change of matter? That's why it's labeled in joules. I could actually take your joules, so we could take like how much you weighed, and we could calculate how many joules you produce, and we could calculate how much energy would be given off if your body blew up. Why we'd want to do that, I don't know, but that's an example of how energy is related to a change in matter. Continuous electromagnetic spectra, that's looking at the electromagnetic spectrum. And then atomic emission is when we're just looking at that short part that we looked at right at the end. And that's all of section 1.